In this demonstration, we are going to define fragments within a molecular structure using Gauss view. This feature is used for various purposes in Gaussian, including modeling antiferromagnetic coupling, computing counterpoise corrections, and so on. We've already opened up the file containing the structure that we'll be working with, in this case phenol dimer. The first thing to do is reposition the molecule within the window so that it's easy to select the atoms that we want. In this case, we want to define two fragments, one for each ring. Now that the two rings are separated in the view, we use the marquee selection tool to select all of the atoms within one ring. Next, open the atom group editor.
This Gauss view tool can be used to define groupings within molecules for a variety of purposes, including onion layers as well as fragments.
The highlighted pop-up menu specifies the kind of atom group that is being worked on. In this case, we use the default choice of fragments. By default, all of the atoms within the molecule are placed into a single fragment, fragment 1. You can move selected items to different fragments using the plus button in the corresponding row of this table. So we click on the plus button in row 2. When we turn on highlighting, we can see that the two rings are now in separate fragments, indicated by the red and green highlighting on the screen. When we close the atom group editor, the highlighting is turned off, but the fragment definitions remain. We can see this when we set up a Gaussian calculation. Looking at the general panel, we see that Write Gaussian Fragment Data is checked. This is a setting that we want, and it is enabled by default when more than one fragment has been defined. We can view the input file by clicking on the Edit button, saving it when prompted. Once the file is open, we can see how the fragment data looks within the molecular specification. The charge and spin multiplicity line now contain entries for the molecule as well as for each fragment individually. In this case, all three of them are the same, specifying a neutral singlet. Within each atom specification, the atomic symbol is followed by the fragment keyword enclosed in parentheses. The argument to this keyword is fragment number. In this case, we can confirm that two fragments are defined. We can now go on to specify the exact calculation that we want to run, and then save and execute the Gaussian job.